Hello, in this video I'm going to talk about parsing trees. So what is a parsing tree? Well, let's suppose we were building a sentence. So we might start by saying, oh look, P and Q, those are both sentence letters, and so according to our first rule, they're sentences. And our third rule tells us that you can put a conditional, an arrow between two sentences and put parentheses around the outside and you get a sentence. So our third rule tells us that this thing is a sentence. Now our first rule tells us that P is a sentence again. Our second rule says, oh, you can put a negation on the front of a sentence and you get another sentence. And then our third rule says again, if you have two sentences, you can put an arrow between them and parentheses around them and you get another sentence. So here we have displayed in this format the way in which the sentence at the top there was built up out of atomic sentences. And that's the way it always works. All of our complex sentences are always built up out of atomic sentences. We start with atomic sentences, we apply our rules to generate new sentences, and then we apply our rules again to those new sentences to get even newer sentences, bigger sentences, and so on. And there's no stop to the process. You can always add another sentence and get an even bigger sentence. So this thing, we call this symbol, these symbols on the right, this is a parsing tree. It displays the way in which the symbol at the top, or the sentence at the top, was built up from atomic sentences to get to it, and all the pieces along the way. Now, if you start with just a sentence, you can reverse the process. You can reverse engineer it. So we would break the sentence into its parts. So, well, first we'd say the main connective is the second arrow, and so it's pieces are, on the one hand, if P then Q and from the antecedent and not P from the consequent. So, right, how is the sentence at the top form? We took parenthesis P arrow Q parenthesis and put it on the left side of the arrow and put a parenthesis on the left side of that. And then we took not P and put that on the right side of the arrow and then put a parenthesis after that. Now we can break both of these down. So we can break the left down into P and Q because that's to build parenthesis P arrow Q parenthesis, we put an arrow down, put P on the left, Q on the right, surrounding the thing with parentheses. And similarly with the not P, we can break that down into P. So a tree is complete. You've done the whole tree when it's all the way down to atomic sentences, to sentence letters. Until you get there, you're not done with the tree. You're breaking the tree down into its atomic components. You're breaking the sentence down into its atomic components. So what's the method? You're going to break a sentence into its parts. So at each step, you identify the main connective, and you break the sentence into its immediate parts, and you finish when you get to sentence letters. So that's what you have to do. And once you get to the sentence letters, you've produced the sentences tree. And so in the module, you'll have to do two things. You'll be given a string of symbols, and you have to figure out, is it a sentence or not? If it is a sentence, you can produce a parsing tree of it, and so you have to do that. And if it is a sentence, you also have to decide, is it in official notation or informal notation? So is it official, informal, or not well formed? And then if it's official or informal, you produce a tree. Note that if a string is not a sentence, there's no tree to be produced because the tree shows how the thing was built according to the rules. If it was built according to the rules, then it's a sentence. So if it's not a sentence, it wasn't built according to the rules, so you can't show how it was built according to the rules, so there's no tree to be done. So when you hear, and here are some examples of non-sentences. So this is not a sentence because A is not a sentence letter. This is obviously not a sentence. So the tree, as I said, shows how a sentence was built according to the rules. And so if you have a not well-formed string, it's not built according to the rules, and so there's no tree to be done. When it's not a sentence, you don't do a tree. So in the next video, I'll just do some examples of parsing problems in the parsing module, and I think you'll find them to be very straightforward.